Thank you all for joining today. We will be talking about a couple of topics today, namely delivering a modern developer experience with the BMC AMI DevX solutions. And I'll kick off by introducing and talking you through BMC's vision statement. So our General Manager, John McKenney, about 6 weeks ago, went to market with what we're calling an AMI vision statement. And what that is basically setting the direction of how the BMC portfolio will be building its capability around artificial intelligence and generative AI, and where we see the solutions starting to move into mainframe organizations and some of the solutions that we're building to incorporate some of these capabilities. So by way of introduction, welcome everyone. Thank you for joining today. My name is Ken Martin. I'm the Regional Director for BMC, looking after our mainframe solutions. And I've been working with a number of customers right across the APJ region on really talking to them about strategies and the vision of the mainframe within their environment. So I'll take you through some of that today. I have my colleagues joined today, Paul Casson and John Attard, who will be talking a little bit more of the technicalities of the DevX portfolio, particularly focused around our development capability and attracting and retaining young developers. So, Paul, if you want to just do a quick introduction, and John, yourself as well. You're on mute, by the way, Paul.
So I'm normally a lot better prepared than that. Obviously, I messed up. That was because I rejoined afterwards. So I'm Paul. I'm a senior solutions engineer with BMC. I'm also a bit of a DevOps specialist and run workshops for our customers around that. And we can talk about that a bit later.
Perfect. Thank you, Paul. John, over to you.
Yeah, so my name's John Attard. I've been with BMC since the acquisition, and prior to that I was with CompuWare for about 18 years. So my specialty has always been in the DevX space, primarily in the expediter area. We've touched a lot on DevOps, and hopefully that's enough to get us going for today.
Perfect. All right, let's start the session, John. So what I wanted to cover today is these 5 key agenda items that we'll talk through as I've just introduced myself and some of the commentary that I'll be making. We're talking about the AMI statement of direction, so everyone's got a bit of a view as to where BMC is moving with our solutions, embracing some of these new technologies that we obviously know and love and hear a lot about in this day and age. Then we'll have Paul and John going through the 4 different areas around AI-assisted code understanding, refactoring code support, automated problem resolution, and DevOps and DORA metrics for ZOS. So that's a little bit about the agenda that we'll be going through. We're going to have some demos. We're going to have some, obviously, some presentation material as well. So we'll get started. So talking about the mainframe and I guess what BMC is doing to develop its capabilities and some of the solutions. We know, and obviously all of you who have joined today are obviously mainframe users and have mainframes within your environments. We know that they keep the business running. I was actually out at a major bank yesterday. We had the head of infrastructure talking about how vital and pivotal the mainframe is to their business. I mean, he talked about it being the crown jewels of the organization. And that's certainly the case that we see on all of our mainframe customers that we talk to right across the region and obviously globally as well. But we also understand that often, the mainframe is felt a little bit different from other platforms. It's usually in the corner somewhere. It doesn't take a lot of space. It doesn't consume a lot of, rack space and things like that. It doesn't consume too much power and cooling compared to, say, the distributed side of things. So it feels different and, tends to sort of operate in a very different way as well. But what we're starting to see is we need to make it simple to use, just like any other platform. The advent of cloud, the advent of, APIs and containers and all of these sorts of technologies, in some cases, the mainframe has been sort of left behind a little bit in adopting and embracing these new types of capabilities. So we believe, with major technologies like cloud and AI that we just touched on, that BMC as a software vendor can help you make your mainframe much easier and much simpler to use, which will ultimately help you deliver faster and maintain a more robust environment. So today I'm going to talk about this vision and what we're doing to try and embrace, I guess, making the mainframe as common or as comfortable as any other platform that you have within your environment. Next slide, please, John. So if we look at, the interest of obviously everyone on the call today, we're all mainframers. We have the mainframes in our environment, as I mentioned. But one of the things we tend to challenge our customers is, do you have a strategy to, in essence, modernize the mainframe? Now, when we talk to a lot of customers, John McKenney and myself actually traveled around Asia Pac just about 2 weeks ago and talked to a number of customers. And a lot of customers are saying, the mainframe again is here to stay. It's going to be here for the foreseeable future. It houses all of our core data requirements. So the question we ask is, what is the strategy you're adopting to try and modernize the environment? And it's not only about application delivery, it's about looking at modernizing the entire environment as a whole. So things like, obviously, app modernization is a very narrow area that you can modernize around, but it shouldn't just be around apps. It should be, how are you going to modernize data, security, operations, and really start to move it from, where it is today to become a modern compatible platform similar to what cloud is. So what we'd like to share today, and this is what we're going to be focusing on, particularly in these key 4 areas, is certainly delivering apps faster and more frequently is critical. So you can support digital transformation, roll out new offerings, and outpace the competition. Right? That's the key in any business today, is how fast can you get to your consumers to offer new capability, obviously faster than your competitors. Unlocking new savings and democratizing some of the data by embracing cloud storage. So, how are you thinking of this? How are you going to make your mainframe more cloud savvy, so to speak, or cloud centric? And we've got solutions and continue to develop around that sort of capability. Moving up the maturity curve to continuously improve on operational resiliency. Even though we've come so far, we still see, many outages and many manual processes. So, again, from a strategic perspective, what are your organizations doing to try and automate, as much as possible, to try and make the mainframe more resilient and obviously provide a better service to ultimately to your customers. Protecting the enterprise from disruption of cyber attacks, that continues and probably is accelerating every day. Climate events, we have floods and bushfires, and all of these things are very pervasive, and probably more so with climate change, and providing faster recovery, including new ways to shore up your defenses. Again, we have a number of innovations in this space. And most importantly, you'll see that supporting a transition to the next generation of talent is a key foundational success factor that we believe will be critical to their mainframe transformation. So how do we attract and retain talent as we see, I guess, the aging workforce, particularly in the mainframe, start to propagate? If we do all this, we'll be in a position with modern interfaces and new interfaces using things like Gen AI and cloud native practices that the next generation will truly, and we've coined this phrase, never mainframed like this, before. So that's the way we're sort of seeing where the investment should be, where the strategic direction should be coming into the mainframe platform. John, next slide, please. Okay, so today the AMI product lines, which stands for Automated Mainframe Intelligence, provide a rich set of capabilities, but most of it is only available from within the mainframe environment. So that is a limitation. Modern cloud platforms expose their capabilities through APIs and CLI, adhering to industry standards, and a model we aim to emulate by making our product line capabilities accessible beyond the mainframe through standard interfaces. This integration into the cloud-native IT environment will enable customers to interact with and utilize mainframes from any location. Our approach will be based on what we're calling AMI Data Services Architecture, which will open our products through APIs, CLIs, and OTel, and is complemented by the AMI GPT Services Architecture, enriching our offerings with GPT capabilities. So this is where we're starting to take our vision in terms of how you'll interact with the tooling that ultimately operates the mainframe. Customers can then choose how to interact with the mainframe using traditional interfaces, 3270, etc., using APIs or CLIs to integrate capabilities and data in process-driven forms from other platforms in cloud-native way, and leveraging Gen AI-infused capabilities such as AI assistants and co-pilots. And we're going to be talking about Code Explain and things like Z Advisors today, which are probably one of the first few, Gen AI capable products that we're announcing as part of this strategy. Next slide, please, John. Okay, so this is just a graphical view of how we see the architecture starting to come about. So today is on the left-hand side there, as you can see. So traditional 3270, JCL, Rex, a PL1 and a classic sort of web GUI interfacing directly into some of the product lines that power your mainframes today. And where we're moving to with this vision is really around this cloud native type style model, and using Gen AI experiences to interact with this platform of capability that then has the underpinnings of all of our solutions, backed up under it. So again, this is a vision statement. We are releasing some products today that you'll hear from Paul and John about, but this is something that we're developing and will continue to develop as we build this vision statement moving forward. Next slide, please, John. If you could just do the build, John, that would be great. So this is, again, just a bit of a mock-up in terms of how we view the platform starting to work. And as you can see on the right-hand side there, it's a GPT or a chat style interface where you'll be able to interact with the technology by putting in something like summarize, Z Advisor, DORA deployment frequency metrics, and it'll start to build things like dashboards and capability for you directly out of these consoles. So we're seeing a lot of that sort of capability that'll come into our tooling. And as I say, this is a vision statement. We're full steam ahead in building some of this capability now and into the future as we invest in a lot of R&D to make these tools sort of cloud friendly and cloud native. Next slide, please, John. I've got a couple more slides to go before I hand over to Paul and to John. So this is also, we get a lot of questions in and around, how do we look at generative AI? Where does it live? Who owns the IP? What sort of environments can Gen AI actually live? So this is the way we're looking at doing it. So you can, have it within within your environments in a hyperscaler or a private cloud or a on-prem sort of environment, if you like. You can deliver it using your type of data and add to your data, including your favorite large language model, and tooling which will allow you to augment with your own tribal knowledge as well. So we don't want to own the IP around this. Customers will make sure that they own it. They can inject their capability into it. But this is something that we are building for the future to consider various models around using, Gen AI and things like large language models as well. So I hope I've given you, next slide, please, John. This is my last slide. I hope I've given you a little bit of a glimpse. Now, this was a very quick, 5-10 minute introduction of where we're going to from our AMI platform of direction. But as you can see, BMC is fully committed to delivering new capability, embracing some of the new Gen AI and AI technology to build automation that really will allow you to build a simpler interface and a simpler interaction that will allow you to innovate faster and deliver faster and really keep the mainframe at the core of your business architecture. So thank you for your time. I will hand over to John and Paul to take through the next capabilities around our DevX platform.
All right, thanks for that, Ken. just before we get fully engaged in this, I don't know if you guys have all seen, but Vivian put something in the chat if you want to use the Zoom chat facility to put in any questions, and we should have some time at the end for some Q&A. All good. All right, so Ken's explained our statement of direction for generative AI and language models. We're going to have a look today at how we can use those to explain new code and give you a real sort of heads up or easy way up for new people learning the mainframe, or even people that have been around there for a long time. A lot of our code on the mainframe is, slightly old, even though new stuff is getting added there as well. And over the years, documentation hasn't exactly been fantastic. And I think lackluster is probably a good way of doing that. So if we look at the areas that we're looking at AI with enhanced productivity, mainframes dev, saving you time, integrating different products, one of the first things we decided to do off the bat was help people understand their code, but also how to split those monoliths up into manageable areas. So John's going to give us a few good demos on that, which, hopefully you will find entertaining and get lots of information out. I actually think it's really cool and quite amazing. The first time I played with it, I was like, oh, wow, I wish I'd had this like way too many years ago. I'm getting a little bit old in the tooth. All right, so without too much, I think we'll let John go through our Code Explain demo. And what that'll do is it'll show you how, quite simply, we can select some code and get a plain English version of what it does. So over to you, John.
Lovely. Okay, just as by way of note, this is a live demo. I get the job of running it, so anything that can go wrong possibly will also just bear with me. And I'm also juggling the PowerPoint, and I'm not a good multitasker. So as both Ken and Paul have been talking, we've stepped into AI a bit with our tools, and we're enhancing that capability. This is our first real step in the generative AI, and it's really aimed at the problem of, like Paul said, code has been around for a long time. It might not have been very well documented when it first came out. It might have been changed from its original documentation. So that presents a challenge when it comes to understanding code. The next issue really is the one that's facing almost everyone in the industry today, and that's trying to Ken made the point, attract and retain the next generation of programmers. And not only are we trying to get new talent into the mainframe environment and make code changes, we're also trying to do it in an agile way. So how long it takes for someone to become like cognitive of what the program is doing and where they need to make the change and the scope of that change has always been an issue, but it's particularly an issue now that we're working agile. We're making more smaller changes more frequently, and we're also putting less experienced developers in front of the mainframe environment. And also, these environments are much easier and much more attractive for younger developers to come in and work. They're familiar with how it works. It's Windows-based. It's all context-sensitive menus. So what I'm going to do first is show you generative AI. I showed you Code Explain. Code Explain is part of our Code Insights product. Code Insights was previously called Program Analysis, and Code Explain effectively works two ways, or very, very generally works two ways. The first way is that I can just right-click anywhere in the body of a program. I don't know if you're familiar with the interface, but this IDE is our Eclipse IDE. We've got an Eclipse and a Visual Studio Code IDE. I've opened a piece of code here, WXD Cob. I've opened it from our SCM tool, which is Code Pipelines. And all I'm going to do is right-click anywhere in the code panel space and say Explain Program. And what this is going to do is it's going to send off that code to our AI. It's going to very, very quickly and very briefly summarize the exact function of that code in plain English. And you can see there, I don't know how easy that is to read on your screens, but it's effectively saying this code reads an input file, writes out the results of a compensation calculation to an output file, and yada, yada, yada. So what I can do with this explanation now is I can go to this comment tab at the top, and I can cut and paste that and insert it at the start of my program so that anyone who comes in now can understand what my program is doing. And if I'm curious about what the code is that's being explained, I can simply click on the code function here. So that's one way of doing it.
I'm going to interrupt you if I do that. The other cool thing about this is because it is a learning language model, that I don't know if you saw when John had that clicked up there, but if the explanation comes back with some words you don't understand or doesn't quite make sense, there is just a regenerate tab at the bottom, and it will give you a different detailed view of that. So it's worthwhile getting the right.
Yeah, regenerate would always give you a different response because it's, it's just like any AI, it's sending it off and it's trying to interpret it, and it doesn't do it the same way every single time. So the second way we can do this is, instead of explaining the whole code, let's say I need to make a change and I want to understand what this particular part of the code is doing. All I need to do is select the code that I'm interested in. I can right click on the code that I've selected, and instead of saying explain program, I can say explain code selection. And once again, it sends that code off to our AI, and it tells me in plain English what that code's doing. It says this code processes sales amounts for each employee, updating regional sales totals and calculating individual, and yada yada. So it's all plain English. That's the regenerate tab. If I clicked on that again, it resubmits the code and should come back with, a similar explanation but worded differently.
And it's done it in context as well. So like when you did the whole program, it gives you a fairly high level view of what that program operates. And now you're doing it on a particular section. It's giving you extremely detailed information.
Yeah. And once again, that's the code that I've asked it to explain. I have the option to comment that code, so I can cut and paste it and insert it into my code. And that's the explanation itself. So I think that's pretty cool. That's our first step into generative AI. This supports COBOL at the moment. It goes GA in October, and then later on we're going to be enhancing this with PL1 and assembler support. The other thing I wanted to show you was also part of our Code Insights tool, and it's the Code Extract. So Code Extract is a tool that we've built into our IDE that helps you take a large, monolithic, potentially multifunctional piece of code that a lot of people check out and maybe have their hands on at the same time, and break it into smaller functional components. And the idea being that those individual smaller functional components are easy to maintain, and also you reduce the risk of many hands needing to be on the code at the same time making changes. So we're trying to do what we can to make this as useful as possible. What we've done here is, I don't know, once again, whether you can see this on your screen very well or not, but you'll see here's all the procedures that are listed in the program. I'm in the same program that I was in before, CWXT COB. You can see that there's a score given to each one of these procedures. That score is just a relative metric. It doesn't mean anything in and of itself, but it's saying that, that the higher the score, the more likely a candidate for refactoring that piece of code is. I can do a variety of things here. I can just extract the code based on taking that one perform group out. And if I do a preview extract, it tells me that not only am I going to take out 6,000, but I'm going to take out these calls that 6,000 makes. The other thing I can do here is I can right click and go configure procedure extract scoring, which affects this score here. And what I can do there is change the weight that it puts on a variety of different aspects of that code. So the business logic statements are, maybe I've added the compensation field and I want to withdraw all the parts of the program that deal with that compensation field and make that its own program. So I can give that higher weight so that would float to the surface. And the other thing I can do here, if I wanted to extract just that code, is I can say select business logic data items, put in my data item here. I don't know I can see hold maybe that. Yeah, so I can choose a data item. It will select the code that contains that data item, and then that becomes, my subroutine that I would call from the program. I'm not going to do any of that. I'm going to do it very, very simply for the point of illustration. I'm just going to take this procedure out here and make this into my own subroutine. So I select the procedure, I click extract code. I give the new code a name. So I'm going to call it new code because that's easy. Now, what I'm doing now is I'm taking the procedure 6,000 out of my program and creating a subroutine out of that procedure. That subroutine is going to be called new code. And my old CWXT COB will then have a linkage to the newly extracted subroutine called new code. So when I click finish on this, I can see it says code extract completed. I click into my project explorer. And the thing to note here is this is in my project explorer. So this is stored in the workspace allocated to my IDE. It's not stored on the mainframe. So at this point, I haven't really changed anything on the mainframe, but I have now the option to review the code that's been generated and compile it and make that its own callable module. So if I go to 6,000, I can see now that that used to be 6,000 print employee report. It still is, but instead of the actual logic in the program that was there originally, what I've got now is a call to new code with the linkage section contained. And if I open new code, I'll see the logic there that was previously in CWXD COB, but now acts as a separate subroutine. All right, so very quickly, that's refactoring support. Now, to help you choose programs that are candidates for refactoring, the other thing we've done is Z Advisor. Let me just log back into that. Really, I've been out of it for a while. Z Advisor's been around for a very, very long time, and we've been doing multiple enhancements to it over the years. It started off as a usage calculator tool. Then we started adding in some of our own metrics, and then we enhanced it with some of the DORA metrics that Paul will be talking about a little bit later on. And then one of the things we've done now to make choosing your refactoring candidates a little bit easier is we've added this refactoring candidate support here, and you'll see that it is there's a warning saying that this is sourced by Code Pipelines. Code Pipelines is our SCM. We get this information from Code Pipelines. And really what we're doing here is, now there's a summary box here. We're saying that out of all the programs in our portfolio, these are the programs that get checked out the most. These are the ones that regress, and these are the ones that fall back the most. A regress just means I've moved it from one stage to another and I've had to move it back. And a fallback means I've deployed it to a runtime environment and it might have failed in that runtime environment. So I've had to fall it back from there. So we can see the most checked. So what we're trying to do is say which one of these programs gets the most hands on it at any one point in time. So which ones are the ones that you check out the absolute most? Maybe we might want to break those into smaller programs so that less people have got hands on them at the same time. Also, maybe these programs, when we do develop them, have the most problems because we regress them more often than we do other programs, or they go into production and they encounter production problems and we have to fall it back out of production. So maybe you want to make these programs easier to maintain, so that the changes that we do make go into production with better quality. So this is what we're doing. You can use this, identify the programs that you might want to refactor, and then part of a sprint would be not just adding new functionality to the programs, but getting people to work on breaking up those monoliths into smaller programs. So that's all I wanted to show you on code refactoring and code explain. Feel free to put any questions in chat. I'm just going to find the next screen for Paul to talk to before I launch into the next part of the demo, which I promise you is a lot more complicated than this part of the demo, so you'll have to bear with me. So just give me a sec.
That's what happens, right? You put AI into stuff and you implement it well, and it makes your life easier. So while it seems very non-dramatic to be looking at all of those things, just being able to get the information out about which programs are the better candidates, and those sliders that John showed a little bit earlier, where you can show, which one's got more duplicate code or needs refactoring, I think adds a lot of value to it, because it means that it's easy to see what you're in for when you're going to look at that stuff. So we covered the scenario of splitting up code and explaining code, and talked a little bit about how we're implementing AI into that. Part of all of that as well is the idea of falling into a more DevOps way of doing things. So, I think everyone here has probably heard the term shift left, right? So you do things earlier and faster. John was showing you the fallouts and the fallbacks and the regressions. So you may have very little problems in production, but your development might still take a lot of time. And that's because, you might have a lot of churning code, and we'll have a look at that in a little bit. So now we're going to take a scenario where we are going to pretend that we have a program that was really well tested, got shipped up into production, right? And then we're going to follow this workflow where we're going to go, the change has been promoted into production. Now, when it's promoted into production, we're then going to put this into a pipeline, right? So we're going to trigger off a webhook that will automatically create a set of stuff for a Band-Aid, which is our, where we see our faults. And it's going to monitor for any failures in that new code, right? Now, it's been tested, it's in production, nothing will ever go wrong. But in case it does, we're then going to be able to pick up on that fact that it's abandoned or failed, right? Now, from that failure point, we're then going to use a Band-Aid to trigger a whole heap of webhooks and different functions. We're going to create a JIRA with a link so that, that problem can be seen quickly. We're going to send off some automated emails so that the people who are working on that or promoted that or, are just interested will get some notifications. We're then going to issue a fallback for the change and automatically fall it back and then redeploy that previous production version, right? Which is the idea that the service will be restored. So in a sort of real worldy scenario, if we think about it, we could have put a change into production that, does a minor change to a customer UI or to a payment system, right? So then when our customer then goes in to transact, and he happens to be the lucky first customer of the day, and something goes wrong with that transaction, rather than having to convene a war room and, have customers reporting that there's a problem, right? And we all know that there is a lag between us having a problem and our customers reporting it. Unfortunately, these days, that lag tends to get you put up on Twitter or X or Downsite Detector, and the media fallout can be huge. So instead of waiting for all that to happen, if we can just automatically regress that change out, put into our last working version, and then present that back to our customers, we haven't had any appreciable downtime, which then is a lot better for the reputation that we carry forward as a company. So anyway, I'm going to let John run you through this scenario. And yeah, like you said, it's live. So fingers crossed it all works.
John and Paul, sorry, I'll just
Yeah,
prompt a question. We had a question come in, and it's to do with John's session. The question is, refactoring sounds interesting, but can it deduplicate multiple modules to find potential reusable components, or is it just to break up monolithic code?
You can look for duplicate code and pull that out and make it a separate module as well. Yep. So that's
one of those sliders that John showed, when we could do the different factoring on what level we wanted to do. So in the one that John was looking at originally, that was, very high on splitting things up. But you could go down, there's one there for generates duplicate code. And if you put that slider up, it will then look better for splitting out those duplicated modules. And that's part of the whole idea, right? Is that if you've got the same code in 4 or 5 different programs, and you can take that into being a single module, it greatly reduces all of your maintenance costs and also the chances for things to go wrong.
Yeah.
Thanks,
all right.
Ken. Yes.
So we're good to launch into the meaty, complicated example that Paul gave us a very high-level view on. All right. So as Paul said, and I will explain this, and first off, just for people who aren't familiar, and I'm sure in the mainframe world, there are people who know what an API is, and there's people who don't, and there's people who know what a webhook is, and there's people who don't, and both of those concepts are pretty important to what we're doing here. A webhook is it's an application-based tool that looks for something to happen, and that something depends on what that tool is. And then on that thing happening or that trap happening, we will do something. And in this case, we've got 2 webhooks that we're really sort of looking at. One is built into code pipelines. It's a native part of our product, and it looks for an action based on an application that. So in this case, we're monitoring this application, and the action is deploy. And on that action, we call our Jenkins pipeline, which is a CI/CD engine, and all that is like a scheduler. You script a whole lot of activities, and it will enact those activities. And part of what that's going to do then is set up a Band-Aid webhook, and that a Band-Aid webhook monitors the runtime environment that I've deployed my code into for a period of time, and it looks for any bends. And if that bend occurs, it, as Paul said before, it will roll back the code that caused the bend. It will install the code that was working previously, and that gets your mean time to restore service down. It also notifies support and will also create a JIRA. So the first thing that we're going to look at, and this is complicated, but it is kind of more the art of the possible. So it's not really important that you 100% understand everything about what we're doing, but I think it's an interesting DevOpsy type example that goes beyond quality gates that we've been sort of hammering for a while and walk straight into, what a real DevOpsy sort of like, this thing happens in my production region and I want to restore service, and I also want to help my developers fix the code. So the first thing that we're going to do here is look at this as a webhook that's been set up by Code Pipelines, which is our SCM. And what it does is that it monitors this application, and on deploy from production, it calls this URL. And this URL is our Jenkins CI/CD engine, and it's going to call this activity from our Jenkins, which is AA webhook demo. And if I go into AA webhook demo and look at my configure, all this does, this is Jenkins, by the way, for people who haven't seen it before. All this does, and once again, it's not important that you 100% understand, how to code this or anything. It's just pointing out what it's doing. And if you see here in the request body, it's going to create a webhook called AACWDEM-CB2 in my webhooks, which is located in my CES instance. It's going to call this, when that webhook is active, it's going to put this in the body of the webhook. So if that bend occurs, it's going to call this URL, which is once again Jenkins. It's going to call this job, which is MKS Band-Aid webhook, and it's passing a whole bunch of parameters to that webhook. And one of those parameters is the program that I'm implementing into production that I want to monitor for change. If it bends, then I want you to do some stuff, and I also set an expiry on that. So you might not want this webhook to be active forever. You might be just cautious about the first couple of days that it goes into production, so you can set an expiry on that. So the other thing I'll note is that's the AA non-deployed. That's going to happen on my promote to production. And on my promote to production, what I expect to happen is that other Jenkins webhook will be activated that will create a Band-Aid webhook and put that in here. So I should see, after doing my deploy, a new Band-Aid webhook being put into my webhooks. So let's just do that. This is my SCM. This is the program that I want to promote. All I do is right-click and go deploy. It's doing a whole bunch of work now, deploying that into my runtime environment. This has been set up for approvals. So once it's gotten to a certain stage, it's going to ask me to approve that. And that's what I'll do. And now if I go into this AA webhook, I should have had a run just this second. And I can see that was the run. And now if I go into my webhooks, hopefully, and thank God for that. There it is. There's my CB2. You never know, do you? So if I edit this, I should be able to say, so when this is what a webhook is. When these conditions are true, do this. So when these conditions are true, when CWDEM-CB2 being run by my user ID bends with an ASRA code in this region, call this URL. And this URL is my MKS Band-Aid webhook. And if we go into my MKS Band-Aid webhook and I go into configure here, and once again, this is very technical, very not easy to understand. But the point being, it's a pipeline, and we're
It
executing this
becomes really
pipeline.
easy to understand over time, right? It's scripted
Yeah.
using Ruby, which is a fairly easy scripting language. And I think, as John showed you, when you're running through that as well, most of these parameters can also be filled in boxes, right? So you don't actually have to know the script. When you look at the event criteria, it automatically sets out. You might want to change that. So if you were originally looking at just one kicks region, but it's been deployed against many, you could blank that field out. So anything that happened in kicks would have that triggered.
Yeah, and that's what I'm doing now. I'm just making this bit more general, so that it's monitoring events for that code, no matter where it events. But effectively, what this is doing, this is what we said before. It's going to send out. It's gathering the event date information. It's going to create an email. It's going to send an email out to me. You can parameterize these scripts any way you like. We've just hard coded them. It's going to create the JIRA, and then it's going to call the fallback API for code pipelines. Now, and this is another point that I wanted to make as well, and I'm just conscious of running out of time.
Yeah.
The more that you walk into a DevOpsy type implementation, the more things like having an API-enabled SCM really make the difference, or having webhooks available in your tools really make a difference, because it's all about automation. It's all about integrating your products together. It's all about, when something happens in one place, I want a whole bunch of things to happen in another place. And without an API-enabled deploy and an API-enabled fallback or an API-enabled regress, you can't do that. So let's just execute this now. So what I've done is I've deployed this to production. I've got a version 5 in production there now. That's the code I just put in. Now what I want to do is I want to cause an append. That append should cause that Band-Aid will cause that a Band-Aid. It has done all morning and all for the last few weeks. Should cause that a Band-Aid webhook to activate, and then that's going to call my Jenkins pipeline, and my Jenkins pipeline is going to do all those magic things, and we should be able to see that happen. So this program is the driving for CWDM CB2. This simply causes an Azure append, and you'll see the Azure append there. Now, if I go back into my pipelines, and I go back in, this is the one that it's called based on the Band-Aid webhook. And there it is. This is where the magic's happening. This is the script executing. You can see it's gathered the Band-Aid information. The next thing it's going to do is compile an email with a link to the Band-Aid information. It's going to create a JIRA in my JIRA system, and it's going to then call the code pipelines API and issue a fallback, and on that fallback, it will also do a redeploy of the previous functional code.
One thing I think is
that Jenkins has sent me my email. The other thing I need to note here is that, sorry, before I go any further, there's an approval on this that I need to click before it can finish.
I think while you're doing that, I'll just point out the fact that because it's executing, in this case, a Jenkins pipeline, and we're just using it on the mainframe at the moment, but that can also trigger off any number of events across all of your platforms at the same time. So that can help orchestrate a fallback if you need to do it for more than just the mainframe.
Yeah, and that's what I mean. It's really the art of the possible. So you can see here, the code's gone from version 5 to version C1. That's the code that was working before I did my deploy. This job's all finished, so we don't have to worry about that anymore. This is the Jenkins, this is the email, sorry, that was sent to me by Jenkins with the Band-Aid link. So let's pretend that I'm a support guy. I can click on that, and like lightning, it brings me up in a Band-Aid interface. I can log into a Band-Aid, HAUJXA0. And that gives me the Band-Aid report. So if I'm, now a support person, I've got all the information I need to debug what happened with my program, just like a normal append. I want to close that. I just want to close the right one, close that. And the other thing it's done is that it's gone to my JIRA system. And if I refresh that, I should see a newly created JIRA ticket. that should have been created 2 minutes ago, once again, with the Band-Aid link on it just there. And that's the magic. So once again, to reiterate, a Band-Aid is a product that we, as a part of our DevX range, that has webhooks built into it that can monitor your system for abends and take action if in a program abends. Our code pipelines has also got APIs and webhooks built into it that you can use to call Jenkins to do a variety of things. And we can also orchestrate deploys into production with other distributed code and then do the fallback based on all of that code if that's what the system dictates. And that's really the bit that I wanted to go through with you guys. Now, I believe Paul is going to pick it up from here and start talking about a couple of DevOps metrics. So let me just get that slide.
All right. So why John get that going? Thank you, John. I'm going to have a quick chat about a bit more about Z-Advisor and also about DevOps metrics. So I guess most of you have probably heard of DORA, whether it's the DevOps DORA or the European DORA for privacy is two different questions, right? The mainframe DORA metric, or not mainframe, sorry, the code development and DevOps metrics DORA started off with a question and a hypothesis that a small group of people had, right? And the question was, what makes the best performing software teams work, right? Who delivers the business goals the best? The hypothesis was that how the team delivers the software has a direct correlation to how that team achieves its goals. And these guys formed a little startup company called the DevOps Research and Assessment Group, shortened to DORA, to dig into it. They surveyed people across a lot of different companies and verticals, bringing together developers and operations teams. And in 2014, they issued their first DORA report, right? Since then, they've become industry standard metrics, and the people that formed the DORA group originally sold it off to Google and made a lot of money. But anyway, so when we're talking about DevOps and DORA metrics, it's all about quality, velocity, and efficiency. And these 5 metrics there were 4. There's added one new one, which is reliability. All are different ways to measure those metrics, right? So and those metrics are, and we'll dig into them a bit deeper, is deployment frequency, the mean lead time for a change, the mean time to recovery, the change failure rate, and the new one, reliability. So if you want to skip ahead one for me, John. Right, so in Z-Advisor, we can give you lots of metrics. John showed you the ones about the code refactoring candidates. When you dig down in Z-Advisor, you've also got product usage, so you can see how many times people are doing things, what they're doing, and across groups. It's really good for recognizing trends in your development life cycles as well, and giving you that high level visibility. When we're looking at deployment frequency, it tracks how developers deploy their code to production, right? Or deploy to end users at a high level. And I think that clarification is sort of essential for mobile because there's a different release process for that. But we can pull that information in and compare things that expose services or APIs. It's all fairly configurable. It's a good a good proxy for understanding how much business value gets delivered to end user and customers, because really good teams that can ship multiple times a day, and we've seen that happen on a number of mainframe sites, they can deliver great value to the business than teams that deploy it less often, right? So if we think back to the old waterfall ways of doing things, which some of us still use, it could take 2 or 3 years to get something new to market. And the company that can get that stuff to market in a week or 2 is obviously going to get a bigger share as long as their delivery is reliable and works well. So the deployment frequency lets you see that, lets you drill into those things so you can see at the average time that things are deployed. Now, the next one we want to have a look is the mean lead time for a change, right? So it's like deployment frequency in that it helps measure velocity, but it tracks the time from when a developer starts working on that code until that code is released at the end, right? In this case, this is our own internal data. We, across our DevX tools, have a lead time of about 17 days. And that seems fairly quick. And it is really, really quick compared to the like 400 or 500 days it used to take us. And hopefully it gets a lot quicker over time, right? But it helps show value and helps show speed. And one of the things when you're adopting DevOps processes, or really any change, is you want to measure the efficacy of that change and how it's delivering value to the business. And this is a great way to do it. So the next one we're going to look at really quickly, this is part of those dashboards, is the change failure rate, right? It tracks problems that, issues that cause problems when they're put into production or even put up into the testing area, right? And this can be really, really important. In this case, we're showing that we have a change failure rate of 14%. And we've got production deployments of 177, and that's because we're looking at production. We could also have stats up there that would show you how much churn there is. Because if you have a fairly simple program or a fairly small program that there's a change made and the developers haven't tested it correctly, and it goes back to the developer from testing, it can take a long time for that developer to get back to looking at that problem. And then they've got to go through that whole process of trying to figure out where they were and the changes they made. We can make that simpler with Code Explain, but reducing that churn is extremely important, right? We know production problems cause us heartache, but the churn is a lot worse when we go down, right? So the next thing we're going to look at then is the mean time to recovery. So this is when something bad happens with a set of programs or a production problem with your deployments or the number of deployments, right? It's a metric or proxy metric for the maturity and the quality of the teams in the organizations. If we think about the example John showed us, we may well have a mean time to restore service that is normally 5 days, but utilizing automated backouts, and that means our service would have been up with, I think, what did that regression take? About 2.5 minutes all up, right? So that's a lot better than 5 days. It means our customers are working again, and we can go back and fix the problem where it's not affecting our customers, and this is what will help. So I think we've covered an awful lot today. We would like to make an offer to you guys. If you wanted to see some more about the AI stuff that we've been developing, or the Code Explain or the Code Insights, or anything to do with what we showed, feel free. We would love for you to reach out. We'd also like to offer everyone some DevOps workshops. This is where we can come in, work with your teams, gather some information, and then come back with a prioritized list for you of modernization opportunities, improvements in your process, how you can streamline things, ways that the mainframe can actually lead the way in the DevOps processes with that shifting left and communication between development and operations teams, and then show you what existing methodologies and technologies that are inside your organization and how they can be exploited, and give you staged implementation plans. Now, when we do this, we try and be as agnostic as we can on the products you're using, and give you that stage implementation plan using what we have or using what you have, rather than just telling you that you should ship everything out and install a whole new way of doing things. And we've found a lot of customers have gained an awful lot of success running these workshops with us. And so we'd like to offer that to you guys as well as part of our relationship. So Ken, how you doing?
Doing good, Paul. Thank you, John. Thank you, Paul. I know we went through this very quickly. I think the demos were awesome, but we certainly have covered a lot of ground in a fairly short period of time. We did have one question come in through the session as well. I didn't want to break your presentation there. We had a question around the refactoring side, so going back to Code Insights. Can we get optimized COBOL code as part of the refactoring process?
It doesn't optimize. It literally takes the logic that's built into the program already and extracts that. So it won't optimize it. You can optimize code through AI. That functionality isn't built into the tool at the
I
moment.
think it's a coming soon type
Yeah,
thing.
yeah.
Tactically, and
But right now, all we're doing is literally lifting the logic up pretty much whole cloth and anything that calls, and then creating a subroutine out of it.
Perfect. Okay, thank you. Hopefully that's answered the question. We had one other question come in with the concept of AI and AI implementations. The question was, can they run AI locally, and who owns the IP of the generated code?
John,
Yep.
I can do that. Yeah.
Well,
So
either one of them. Yeah, you can definitely. There's I think 3 implementation models for the LLM. One's in the cloud, one's on premise, and one's using our LLM model. So yes, you can absolutely have the language model running on a local machine. It runs through Unix, and we don't. The IP isn't permanent. I'm sorry, not the IP. The code isn't permanent. So once we do the run the AI against it, it evaporates, and we don't see it at all. So you definitely own the IP for the code that it generates.
Brilliant. Excellent. Okay, I think we're done with the questions and we're coming up to time. So it's 2:29. So Paul and John, thank you for running us through the session today. As I mentioned at the start of the session today, the Code Insights product and the Code Explain, the first foray into generative AI and AI capability that we're starting to build into our products. You will see a whole raft of capability, including the dashboard style concepts and things like that we're obviously talking through today, coming in future iterations. So we're investing very heavily in building mature, current API driven, CLI driven capabilities to help you on your journey to, if for want of a better word, cloudify your mainframe environment. Is where we're moving to. So hopefully you've got a few insights from listening to today's session. As Paul mentioned, we are open to do a workshop with you to understand how your development processes work today and give you some ideas of what can be fine-tuned and what can be created in a more agile and DevOps style methodology. So please, if there's interest there, reach out to your account teams, and we're more than happy to set those sessions up for you. So thank you for joining today. Yes, Paul.
Before you signed off, I just want to say one more thing.
Sure.
You've never mainframed like this before, right?
What a way to go. What a way to go. Thank you all for joining. Appreciate your time, and we'll see you at the next webinar. Thank you so much.